this is an introduction to Riemann sums. Riemann sums is a form of approximation that we can use to find the area under a curve. It comes in three forms: left Riemann sum, a right Riemann sum, or a midpoint or a mid Riemann sum. And so usually most of the questions you deal with will provide you with what type of Riemann sum it's asking for. So when you get a question related to Riemann sums, it will probably or usually give you these four components: the function, the interval, the number of subintervals, and the type. The function in this case is an equation, but it could also be in the form of a data table or a graph. So in this case, f of x equals x squared is our function, and the interval is 0 to 2. It can also be called the domain. The number of subintervals is 4, which is basically if the domain is 0 to 2, how many times is the domain broken up into pieces. So 4 tells us that this domain is broken up into 4 pieces. And the type, which as I mentioned before, can come in 3 forms: left Riemann sum, right Riemann sum, or mid Riemann sum. In this case, it's a left Riemann sum. So the first part in solving a Riemann sum problem is to use the equation b minus a over n. Now, b minus a over n might look complicated, but it's actually just figuring out how big or how small is each of the sections that were broken up the domain into. So say for example this is our domain from 0 to 2, and it tells us that the number of subintervals is 4. So we break this up into 4 pieces. What we need to calculate is how big is each of these subintervals. Now we can do that intuitively, or we can use the formula b minus a over n. B in this case is the last point in the domain, which here is 2, and a is the first point in the domain, which is 0 in this case. N stands for the number of subintervals, which is 4. So plugging all that in, we can get our number, which is 0.5. Once we have this number, we can figure out what the endpoints are. The endpoints helps us to approximate the area under a curve. So what we can do now is take the first point in the interval, which in this case is 0, and because it's a left Riemann sum, we start with 0. If it's a right Riemann sum, we start with a different number. I'll go over that in a minute. So we start with 0 because it's a left Riemann sum. So just keep in mind, if it's a left Riemann sum, you start with the first point in the domain. So 0 in this case. And you add this much consecutively until you reach 2. So you add 0.5 to 0, which is 0.5. And then you add 0.5 to 0.5, which is 1. And then you add 0.5 to 1, which is 1.5. Now, how do you know when to stop? You stop, it depends on the type of the Riemann sum. If it's a left Riemann sum, you stop 1 before the last number in the interval, which in this case is 2. So now we know if we add 0.5 to 1.5, the next number will probably be 2. Now because it's a left Riemann sum, we stop 1 number before that. So these are all of our endpoints: 0, 0.5, 1, and 1.5. Now to calculate the area under the curve, all we need to do is take this number, 0.5, and then brackets. It will be multiplying everything inside the brackets with 0.5. And then we plug these endpoints into the function. So if you plug the 0 into the x squared function, you get 0. and then you add every endpoint after plugging it into the function. So 0.5 square is 0.25. So you can add that here. 1 square is 1. And 1.5 square is 2.25. Right? So now all we need to do is add 2.25 plus 1 plus 0.25 plus 0. You get 0.5 times 3.5. And that gives us 1.75. And that is the area under the curve. Now you might be asking, what curve are we talking about? We didn't get a graph in the question. Like I said, you can be given an equation, a data table, or a graph. So if you want, we can construct a graph with the equation. The equation of x squared is usually, or it is this, right? And so the interval is from 0 to 2, and the subintervals are 4. So basically, we found the area under the curve, which is this. So if you wanted a more visual representation, this is it. Now, same concept, except we have a different equation, different interval, same number of subintervals, but a different type of Riemann sum. So again, we always start with this equation, b minus a over n, and b is the last number in the interval or domain, which is 5, and then a is the first number in the interval, which is 1, and then the number of subintervals, which is 4. So this gives us 1, and the next step was figuring out if it's a right or left. It tells us it's a right Riemann sum. So what we need to do is, instead of starting with the first number, like we did with the left Riemann sum, we start with the second number. So in this case, 1, it's better to write down all the numbers and then erase the first number. So you start with 1, and then we add 1, and then another 1, 4, and then 5. Now we ended with 5, which is the last number, because it's a right Riemann sum. In the case of the left Riemann sum, we keep the first number, which is 1 in this case, and then 1, 2, 3, 4 would have been our endpoints. We would not have included the last number. In the case of a right Riemann sum, we remove the first number and we keep the last number. Since this is a right Riemann sum, these are our endpoints. Now, just like before, we multiply by this number, and in brackets, we plug in these endpoints into the function. Okay? Now, you can just write root 2 plus root 3 plus root 4 plus root 5. And now you can calculate that using a calculator. But whatever you get will be the area under the curve. So in this case, we have a function f of x equals to e to the power of x. Interval is 0 to 1, and the number of subintervals is 5, and the type is a left Riemann sum. As always, we start with our equation b minus a over n, and you have 1 minus 0 over 5, so you have 1 over 5. So since we have this number, and we're doing a left Riemann sum, we start with the first number in the interval, which is 0, and then we add 1 over 5, which is 1 over 5, And then when we add 1 over 5 again, we get 2 over 5, 3 over 5, 4 over 5. Oh. And if we add 1 over 5 again, we'll get 1. So since it's a left Riemann sum, we will stop right before the last number in the interval. These are our endpoints, and what we do is we multiply 1 over 5, which is the b minus a over n, and we multiply all of that. We multiply everything inside the brackets with 1 over 5. So we plug in 0 to e to the power of x. So when you type in into our calculator, e to the power of 0 is 1. E to the power of 1 over 5 is 1.22. I'll just write e to the power of 2 over 5 plus e to the power of 3 over 5 plus e to the power of 4 over 5. And so when we add all of that up, type that into the calculator, you get 1 over 5 times 6.76 approximately. And that times 1 divided by 5 is 1.35. So that is our answer for this question. Now, in this question, they give us the same 4 components: the function, the interval, the subintervals, and the type. But in this case, we don't have an equation, we have a table. And that changes up some things. But as always, we'll start with b minus a over n. Now, I did mention that the interval is the same as the domain. And so the domain is the values of x. So in this case, the last or the highest domain number is 5. So 5 minus the first number, which is 1. 5 minus 1 divided by the number of subintervals. In this case, it's 4. That gives us 1. Now, because it's a left Riemann sum, we start with the first number in the interval, which is 1. We add 1, or because it's a data table, we do a slightly different approach. We multiply by 1, and we skip the step where we find the endpoints and we plug it in. Because when a data table is given to you, all you need to do is multiply by this number 1, and f of x values are already given to you, so you don't need to calculate it with an equation or anything. So because it's a left Riemann sum, we start with the leftmost side, and so we take 2 plus 3 plus 5 plus 4. Now we skip 6 because, as I said before, with the left Riemann sum we always exclude the last digit. With the right Riemann sum we keep the last digit but we exclude the first digit. Because it's a left Riemann sum, we will just do that. And so 2 plus 3, 5, 14, and that gives us 1 times 14, 14. So that is the area underneath the curve for this problem. Same principle, we have a table, interval, subintervals, and the type. b minus a over n. And for this question, it's the same, 5 minus 1 over 5 actually. So we get, oh, my bad, 5 minus 0 over 5, because you're taking the last digit in the domain, which is 5, subtracting it by the first digit in the domain, which is 0, and dividing it by the number of subinterval, which is 5. So we get 1. And for this question, we have a right Riemann sum. So we take the second digit onwards. So we get, oh, and we take the g of x values, not the domain, because you're getting, for the numbers inside the brackets, we need the y value. So we take 2 plus 4 plus 3 plus 5 plus 7. Now again, if it was a left Riemann sum, we would exclude 7 but include 1. Now in this case, we can just add all these up and multiply by 1. So 6, 9, 14, 21. So our answer for this question is 21. That is the area under the curve.